All right, this little problem seems pretty straightforward and simple. So reminder on how we did this. We went through this in class to get the sketch of the tangent. Remember, the tangent is opposite over adjacent. So we went like that. We put a triangle in here. So the opposite side over here was the y side. The adjacent to the reference angle was the x side. So we had y over x. We also did on the unit circle, that's 1. So sine and cosine. So that was sine over cosine as an option. But let's see where we're at with our problem. So when we do this, the positive rotation, negative rotation on there for the tangent, this is going to be an asymptote and an asymptote down here. So that my pi over 2 up here and my negative pi over 2, because those are x's are going to be 0, can't divide by 0. And then as we rotated here, this was becoming, as we moved toward the pi over 2, it was getting to be a larger number. So and at 0 right here, over the x, the sine over the cosine was 1x, but 0 over 1 is 0. So it went through the origin. So where's that graph? We need to go through the origin, but it's supposed to be going over to this side. So that is the cotangent. This one didn't even go through the origin, nor did this one. Leaves us with D. All right. Moving on. That seems like what we talked about when we did that problem in class. So keep going. Is the function odd? Remember, for odd, when you take a look at, if you put an x value in and a negative x value into the function, you're supposed to get opposite y's. So right here, if I come over here and look, I've got a positive, I go negative that same amount, I got a negative. So yep, that would be an odd function. Even means they're both positive, they reflect over the y-axis there. So yep, that's odd. That seems like an odd function. So continuing on, is the y-intercept equal to 1? So on my y-axis, is it a 1? No, it went through the origin. So is my y-intercept equal to 1? Oh, no, that's not right. What about, is the range all real numbers? So range, y. Does it go down forever and up forever? You bet they did. Right up there on those graphs. They went down forever up. So yep, it sure is. All right. Moving on. Is the range all real numbers? Range, the y's. What did I just, is the range all real? Oh, except. I didn't read the except. Except. Oh, I didn't read the whole question. I just stopped. Okay, so that one's on me. All right, so keep on keeping on here. Is the range all real numbers? I didn't read this. All the zeros are in the form of on the whole pies. So let's go back up here and look. Look at this graph over here are the zeros on the whole pie. So that one, this one. Yeah, that would be a pi right there. That'd be a negative pi. And then we'd have another one over here. So yeah, their zeros are on the pies. And lastly, is the interval for the graph of the principal cycle negative pi over 2 to pi over 2. And so the principal cycle, when you take, that would be this part right here. So yes, that would go from my negative pi over 2 here to my pi over 2 here to get that section of the graph. So you betcha. All right. And that's some of the key features there of y equals the tangent of x. Hope that helps you out. Having a good day. Seek out more if you need them. Lots of resources out there on YouTube, videos you can watch. Tangent of x, key features, and graph.